All right, in this section, we're going to apply pretty much everything we talked about in the previous section. Now, before I tell you what exactly we're going to do, I want to make sure that you're in your optimum state. You're not tired, you're not playing with your phone, you're not talking to people around you, you're fully focused. Because this section is super important and I need your full focus. We're going to go really deep and look at some hardcore coding techniques. We're going to work with a lot of code, and if you're not fully engaged, you're going to get lost. And trust me, this section, in my opinion, is the most important section in this course. You don't want to miss it. Because the stuff I'm going to teach you, you're not going to find them in other courses out there, I promise. So here's the question. Are you ready for this section? If you're tired or half engaged, please stop watching. Don't spoil this section. Go take a break, come back, watch this section later on today or tomorrow. Here's the mortgage calculator project that we built in the first part of the series. I've included the source code for this project in a zip file that I provided early on in the course. Now, if you missed the first part, don't worry. Let me give you a quick overview of this project. So when we run this program, we have to answer 3 questions. The principal or the amount of money we want to borrow. Here we have to enter a value between 1,000 and 1 million. So if we enter an invalid value like 0 or -1, we get this error message. Let's say $100,000. Next, we need to enter the annual interest rate. Let's say 4%. And we want to pay this off over 10 years. See what we get. So in this report, we have 2 sections. The first section is the mortgage section. So here we can see our monthly payments. And below that, we have another section that is our payment schedule. So every month, as we contribute this amount, we can see the remaining balance. So it starts from 99,000 and over 10 years, you can see this amount eventually gets down to 0. So this is our mortgage calculator. Now, if you look at the code for this project, you can see that this code is very procedural. We have a bunch of unrelated methods. For example, here we have print payment schedule, which is purely responsible for printing something on the console. Here we have read number, which is responsible for reading a value within a given range. Then we have calculate balance. We also have calculate mortgage. And all these methods are part of the main class. So we don't have encapsulation. We don't have abstraction. We just have a bunch of methods calling each other. This is what we call procedural code. Now, in this section, we want to refactor this code towards an object-oriented design. Refactoring, as I told you in the first part of the series, means changing the structure of the code without changing its behavior. So we don't want to change the functionality of this program. We just want to change how we structure our code. Now, in this section, we want to take a different approach. Instead of you watching me do this, I want you to treat this as a project, as an opportunity to practice all the concepts that you learned in the last section. So please do not continue watching until you solve this problem. This is extremely important. You cannot learn how to ride a bicycle by watching someone. You have to do it. So spend 20 to 30 minutes, refactor this code, extract the classes that you think are necessary here, and then come back see how I would solve the same problem. So get the source code and start refactoring this project. One of the common questions amongst beginners is, what classes do we need in our application? Well, that depends on the concerns or responsibilities your application deals with. Let me give you a metaphor. Think of a restaurant. In a restaurant, we have different people working together to provide a service. Each person has a clear and predefined responsibility. So we have a chef, a waiter or waitress, a cashier, and so on. So each person in a restaurant is like an object. All these objects collaborate together to provide some service, right? We should design our classes or objects in a similar fashion. So we should find the concerns or responsibilities in our application and make sure that each class has a single responsibility. So back to our code, let's have a quick look at what we have here to figure out what responsibilities we have and how we can give these responsibilities to different classes. So in our main method, we're calling the read number method. This method is responsible for reading a number from the console. So potentially we can create a console class and move this method there. Then in the future, whenever we want to build a console or command line application, we can reuse that class to read a number from the console. Okay? What else do we have here? Here we're calling the print mortgage method. This method is calling the calculate mortgage method. See, we are just calling methods one after another. This is procedural programming. We are not using objects. We don't have encapsulation. We don't have abstraction. So this print mortgage method is responsible for printing the monthly payments in a nice format, like some kind of a report. So potentially we can create a class called mortgage report and move this method there. What else do we have? Print, payment, schedule. Very similar. All we are doing here is creating some kind of report. So this method is using the calculate balance method to get some data, and then it prints it on the console. Now you might be asking, wouldn't that be better if we move this method to our console class? No, because that console class is a generic class. It doesn't know anything about mortgage. If we move this method there, then that class is going to get a little bit bloated with something that it shouldn't be responsible for. This is like a restaurant where the chef comes and takes orders. So we want to make sure that each class or each object has a single responsibility. Our console class is going to be generic. It only knows how to read values from the console. It doesn't know about mortgage or any other kind of domains. Next, we have the read number method, which we talked about. After that, we have the calculate balance method. Here we have some basic mathematical calculation for calculating the remaining balance after a number of payments. And finally, we have calculate mortgage, very similar to the other method. Now look at the parameters of these two methods. So here we have 3 parameters: principal, annual interest, and years. And we have the exact same parameters in this other method. This is what we call procedural programming. We're just calling methods and passing values around. Now, whenever you see you're passing the same values to multiple methods, that is a great opportunity to apply the encapsulation principle. So here we want to encapsulate these values and the methods that apply on them, like calculate balance and calculate mortgage, inside a single object. So instead of passing these values around, we want to store them in the fields of a class. And then our calculate balance method is not going to have 4 parameters. It's only going to have this parameter. So this was my initial analysis of various responsibilities we have here. Over the next few lectures, we're going to refactor this code step by step. All right, the first thing we want to do is to extract the read number method and put it inside a class called console. First, I'm going to show you the poor way of doing this, and then I'm going to show you a better way. So here's the poor way. We go to our project, and inside this package, we add a new class. We call it console. Okay. Now we go back to our main class. So here's where we're calling the read number. Let me show you a shortcut to jump to the declaration of this method. So on the top, under the navigate menu, look at the shortcut for declaration. On Mac, that's Command and B. So we press Command and B. Here's our read number method. So the poor way of doing this is by selecting this code, cutting it, and then going back to the console class and paste it here. Now, why is this bad? You can see that here we have a few compilation errors. We haven't imported the scanner class. That's why IntelliJ doesn't recognize it. Also, the code in our main class is broken. So wherever we call the read number method, now we have to manually prefix it by console dot. So this is the poor way of refactoring this code. We'll end up with several compilation errors. Now let me revert these changes back. So undo. Okay, here's the read number method in our main class. We brought it back. I'm going to delete the console class. There you go. All right. Now let me show you the proper way to refactor this method. So we put the caret on the method name, and on the top, under refactor, look at the shortcut for refactor this. On Mac, it's Control and T. So wherever we press Control T, IntelliJ suggests a few refactoring techniques. Here we want to move this method to a different class. So I'm going to select move here. On the top, you can see that we are moving this method from this class. Where do we want to move this to? com.codewithmosh.console. Now we don't have this class yet, and that's why it's displayed as red. But don't worry, IntelliJ is going to automatically create it for us. Now on the right side, look at the visibility. So here we have various access modifiers. We want to make sure that this method is public, so it can be called from outside of this class. Now let's click on refactor. It's asking that this class doesn't exist. Do you want to create it? Of course. So here's our console class. IntelliJ moved all the code here. And because we're using the scanner class, it also imported it on the top. So we don't have the compilation error that we had earlier. Also, it changed our main class. So on the top, where we call the read number method, it prefixes it with the console class. This is what we call safe refactoring. So instead of us manually moving code around, we use IntelliJ. This is much faster and produces fewer errors. So here's our console class. Currently, we have a single method here. That is our read number method with these 3 parameters. Prompt, which is the question that we display, as well as min and max. Now, what if we want to ask a question, but we don't want to enforce a valid range of values? All we want is a number. This is an opportunity for overloading this method. Now, this is not part of the requirements. We don't currently need it in this application. So technically, we shouldn't implement this method unless we need it. But I thought to include it in this lecture to review the materials you learned in the last section. So let's overload this method. On the top, we're going to create another public static method. And by the way, both these methods are static because we only have a single console to work with. In console applications, we don't have multiple consoles. So it makes sense to use static here. Now here we want to return a double. We call it read number. We add this prompt, but we're not going to add the other 2 parameters. So like this. Now here, once again, we can use a scanner object, but we're not going to have this infinite loop as well as this data validation logic. Our implementation is much simpler. So we simply return scanner.nextDouble. And by the way, here we have a problem from the first part of the course. Here we should call nextDouble because this method returns a double. Now here we have an issue. Every time we call the read number, this class creates a new instance of the scanner object. So this is an opportunity for us to declare this object as a static field. So over here, we're going to declare this as a private field because it's implementation detail. We don't want other classes to use this field. It's only used internally inside this console class. So private static scanner, and we can initialize it right here. New scanner with system.in. And with this, we can remove this line of code as well as this line over here. Now back to our main class. When we call console.readNumber, you can see this method is overloaded twice. The first implementation forces the user to enter a value within this range, whereas the second implementation doesn't care. It simply reads a number and returns it. So this console class is very handy. Whenever we want to read a value from the console, we can simply use this class. We don't have to create a new instance of the scanner object. Okay? Next, we're going to work on the print mortgage method. All right, now we're going to work on these 2 methods, print mortgage and print payment schedule. Where should we move these methods to? Well, because both these methods are about reporting, I would prefer to create a new class called mortgage report. So once again, we're going to use the refactoring tool in IntelliJ. With the caret on the method name, let's press Ctrl and T and move this method to a new class. We're going to call that code with Mosh, mortgage report. Now in this list, currently only this method is selected. Let's also select print payment schedule and make sure that both these methods are going to be public. Now let's refactor. Yes. So here's our mortgage report class with 2 static methods. Look at line 7. Here we're calling the calculate mortgage method of the main class. Now technically this method shouldn't be there. It should be part of another class called mortgage calculator. So we're going to refactor that soon. But before we do so, let's have a quick look at our main class. So IntelliJ automatically updated our main method. We don't have any compilation errors. So here we're calling the print mortgage method of the mortgage report class. All right, so we're done with this step. Next, we're going to move the remaining methods to the mortgage calculator class. All right, now we're ready to move these calculation methods to our mortgage calculator class. So we put the caret on the method name, press Ctrl T, and move this. Here we should also select calculate mortgage. So we want to move both these calculation methods to a new class called mortgage calculator. We want to make sure both these are public. Let's go ahead and refactor. So here's our new mortgage calculator class with 2 static methods. Let's have a quick look at our main class. See how much code we reduced? Previously, we had several methods in this class, and all of them were unrelated. They were doing different things. Now everything is in the right place, but we're not done yet. Let's look at our mortgage calculator class. Earlier, we talked about the parameters of these methods. Both these methods have these three parameters: principal, annual interest, and years. So here we want to apply the encapsulation principle and store these values in the fields of this class. So on the top, let's declare a few fields: private int principal, private float annual interest, and private byte years. So now this class is going to have some state and some behavior. This is encapsulation in action. Now here we need to add a constructor and initialize these fields the moment we create a calculator object. Let me show you another shortcut. So here on the top, under the code menu, look at generate. The shortcut is Command and N on Mac. So Command and N. Now here we can ask IntelliJ to generate something for us. It can generate a constructor, a getter for any of these fields, a setter, a getter and setter together, and other stuff. Now let's generate a constructor. Here we can see the private fields in this class. We can select the fields that we want to initialize using this constructor. So I'm going to select all of them. And now IntelliJ is going to create a constructor with 3 parameters, and it's going to initialize these fields using those parameters. Take a look. So here's our constructor. We have these 3 parameters, and inside this constructor, we're initializing our private fields. All right, now that we have these fields and we can properly initialize them through our constructor, it's time to remove these repetitive parameters from our methods. So once again, we put the caret on the method name, press Ctrl and T. This time we want to change the signature of this method. So here are the parameters that we currently have. We can select those that we don't want and delete them. Now let's go ahead and refactor our code. IntelliJ is giving us a warning because we have used these values in this method. That's totally fine because now we are storing these values in the field of this class. So let's continue. All right, we have a few compilation errors. This method cannot see annual interest, years, and principal. But didn't we declare them as private fields in this class? Yes, we did. However, this method is declared as static. So as I told you before, static methods can only see static fields of a class. These fields belong to a mortgage calculator object, not the mortgage calculator class. So now we need to convert this method to an instance method. Once again, we use our refactoring shortcut, Ctrl-T. Look at the third option, convert to instance method. Now, unfortunately, in this case, IntelliJ couldn't do this for us. This is one of those situations where we have to manually jump in and modify code. So I'm going to remove the static modifier. Now you can see that these compilation errors are immediately gone because we can access these private fields in this class. Now our calculate balance method has only a single parameter. Let's put this on the same line. That is better. All right. We have to repeat the same steps with the calculate mortgage method. So first we need to remove these parameters. Ctrl-T, change signature. I'm going to select all these parameters and delete them. Let's go ahead and refactor, continue. We have the same problem as before because this method is static and it cannot access these fields. So let's remove the static modifier. Now we have made a few changes to this calculator. We need to find out what classes are affected. So we put the caret on the class name, right click, and find usages. So this class is used twice in the mortgage report class. Let's double click this line. Okay, this is where we are using our mortgage calculator. And as you can see, we have a breaking change because the calculate mortgage method is no longer static. So here we need to create a mortgage calculator object. Let's do that real quick. So for calculator, we create a new mortgage calculator. We need to pass 3 arguments. These are principal, annual interest, and years. So let's pass this here. Principal, annual interest, and years. Now we're going to use our calculator object and the compilation error is gone. We have to do the same step over here. So once again, we have to create a mortgage calculator object, but we don't want to repeat this. So it's better to declare this as a field inside this class. So on the top, let's put the caret on this calculator object, press Ctrl T. You want to extract a field from this local variable. Let's go ahead with that. Now this variable is highlighted, so we can change the name if you want to. I'm happy with calculator, so let's press enter. Now we have a private static field of type mortgage calculator in this class. But this field is initialized in this method, and this is not good because we have to remember to call the print mortgage method first, so this field is initialized. We're going to fix this issue in the next lecture. As I told you in the last lecture, we don't want to initialize this private field inside this print mortgage method. The right place to initialize this is inside the constructor. However, we use constructors to initialize instance fields, but this calculator object is declared as a static field. And also, both these methods here are declared as static. So we want to move away from all these static members and have a proper object that has some state and some behavior around that state. As I will show you later in the course, we shouldn't use static fields and static members that often. They're troublesome. We should reserve them only for situations where we're dealing with a concept that should be only in a single place. In this case, we don't want this mortgage report class to have a single mortgage calculator. Perhaps in a real application, we want to have multiple windows. Each window displays a report, and each report can use a different calculator object with different values. So we don't want to have a single instance of this calculator object in memory. So let's convert this to an instance member. Once again, we press Ctrl T. Unfortunately, at this time, we don't see the option for converting this field to an instance field, so we'll have to do it manually. Let's remove the static keyword. Obviously, now we have a breaking change because this static method cannot see our calculator object. So let's put the caret on the method name, press Ctrl T, and convert this method to an instance method. Now we want to make sure that this method is going to be public. Let's refactor it. Beautiful. So here is where we're initializing our calculator field. Let's delete this line. So in this method, we're simply calling calculator.calculate mortgage. Now, note that these parameters are grayed out. We no longer need them because we encapsulated these values inside our calculator object. So there is no need to pass these parameters around. We haven't used them anywhere in this code. So let's change the signature of this method. We press Ctrl and T, change signature, and remove these parameters. Refactor, done. Now we need to make the same changes to the other method. So first we need to make it an instance method so it can access this private field. Convert to instance method. We want to make sure it's public. Refactor. Good. Now, these two parameters are grayed out. We haven't used them anywhere in this method, but this method needs the years parameter because it's used here on line 13. Now we can read this from our calculator object. So again, there is no need to pass these parameters around. So I'm going to change the signature of this method and remove all these parameters. Refactor, continue, good. Now here we have a compilation error because we don't know how to get the number of years. So let's prefix this with calculator dot. Now this is a private field in this object. We don't want to access it directly, so we should create a getter for it. Let's call that get years. Now this getter doesn't exist yet, but we can easily create it. Look at this light bulb. We can activate this using Alt and Enter. Here we have a few options. Create method, create property, which means it's going to create a getter and a setter, and create read-only property. This will only create a getter. Let's go with this. Now we are inside our mortgage calculator class. IntelliJ is confirming the return type of this method. Let's go with short. And here we have this return statement to return the value of the years field. Press enter to confirm. Good. Now back to our mortgage report. So we fixed this problem, but we have another compilation problem because this calculate balance method is no longer static. So here we need to replace this mortgage calculator class with our calculator object. We're almost done. The last step is to initialize this calculator field through a constructor. So we put the caret over here. We can activate this light bulb with Alt and Enter and ask IntelliJ to create a constructor to initialize this field. So let's go with that. There you go. So here's our constructor. This constructor has a calculator parameter, and we're initializing this calculator field using this object. So we have made several changes to this mortgage report class. We added a constructor. Now we need to find out where this class is used to make sure we don't have any compilation errors. So let's right click on the class name and find usages. So this class is used twice in our main method. Let's take a look. There you go. So here we have a compilation error because we don't have a calculator object to pass through the constructor of the mortgage report class. But that is very easy to fix. So here we are reading these values from the console. We can simply create a calculator object, new mortgage calculator, and pass these three values: principal, annual interest, and years. Now, we pass this calculator object here. We should also fix these two lines. We don't need to create two new objects. Let's just create a report object, new mortgage report. We pass the calculator, and we replace these expressions with a reference to our report object, like this. So in our main method, first we read three values, then we create a calculator object, and finally we create a report and print it on a terminal. Through all the refactorings we have done so far, we have improved the design of this application significantly. But we're not done yet. Look at these static fields we have declared in the main class. These fields don't really belong here. Where do you think we should move these to? Well, let's find out who's using them. So right-click, find usages. As you can see, we're using these fields 4 times inside our mortgage calculator class and once in our mortgage report class. So these fields are mainly used for calculations. We should move them to our calculator class. So let's collapse this window. Control-T. We're going to move this to mortgage calculator. And look at the shortcut I'm using here. I'm not typing the full name of the class. That's very tedious. I'm using a few characters in the name, like MC. This is what we call camel humps. So with this, we can quickly look up classes in IntelliJ. All right, let's select this class. Now, in this list, I'm also going to select this other field. And we want to make sure that both these fields are public so the report class can use them. Now, later I will show you that we can refactor the report class even more. So it's going to be independent or decoupled from these fields. And then we can make these fields private so they will be part of the implementation. Let's refactor this. All right, so here's our mortgage calculator. We have 2 public static fields on the top. Below that, we have 3 instance fields. So the data that we store in these 3 fields represent the state of our calculator object. Now look at this method here. Our calculate balance method has a single parameter. Previously, we had 4 parameters. Look at the other method, calculate mortgage. No parameters because we're using the fields inside this class. This is the benefit of object-oriented programming. We're encapsulating data and operations around data inside a single unit. However, here we have a tiny problem. In both these methods, we have duplicated some code. How we calculate the monthly interest and the number of payments. Look at these 2 lines. We have the exact same lines in this other method. We're going to fix this issue next. We have duplicated these expressions twice in this class. To remove the duplication, we have 2 options. One option is to promote these local variables as private fields in this class and initialize them in the constructor. So here to calculate the monthly interest, we need to know the annual interest as well as these 2 constants. So here in the constructor, we get the annual interest, and this could be an opportunity for us to set the monthly interest. However, if we change the annual interest in the future, we have to recalculate the monthly interest. Currently, we don't have a setter for setting this field, but if we implement it in the future, we'll have to repeat this logic one more time. So we have to calculate the monthly interest once in the constructor and once in the setter of the annual interest field. So this is not a good option. A better approach is to extract this expression as a private method in this class. We call it get monthly interest. So let's select this expression. Now we activate our refactoring menu using Control and T. You cannot see it properly here, So I'm going to bring this menu from the top. So refactor, we want to extract a method. So here's the name that IntelliJ is suggesting, get monthly interest. And this method is going to be declared as private because this is implementation detail. We don't want to expose this to the outside. So this is abstraction in action. Now let's refactor this. Now here's what I love about IntelliJ. It detected that we have repeated this expression somewhere else. So it's asking us if you want to replace this other occurrence. Let's click on all. All right. So now we have this new method, get monthly interest. In our calculate mortgage method, we are calling get monthly interest to set this variable. If we change the annual interest in the future, this method will always return the updated monthly interest. Now we're going to repeat the same steps with this second expression where we calculate the number of payments. So let's select it, go to refactor, extract method. This method is going to be called get number of payments. I'm happy with the name. Let's refactor it and replace both occurrences. Beautiful. All right, now let's review the entire code in our mortgage calculator class. So we have these static fields on the top. Below these, we have our instance fields. Here's our constructor. Here we have our calculate balance method. Below that, we have get monthly interest, which is like a getter. Now, it's a good convention to move all getters and setters to the bottom of the class. This makes it easier to read and understand the code. So this get method shouldn't be here because below that, we have another calculate method. So I'm going to select these few lines. Now let me show you another cool shortcut. Under the code menu, look at these two items. Move line down and up. Look at the shortcut. On Mac, it's Alt, Shift, and down. So with these lines selected, I'm going to press Shift, Alt, and down. And now we can bring this code down and see how it fits. So let's scroll down. Okay, that's better. So we have all our getters in a single place. Get monthly interest, get number of payments, and get years. These two methods are declared as private because they're implementation detail. However, get years is declared as public because other classes need to use it. So it's part of the public interface of this class. Now, what is beautiful about this code is that here, we don't have anything about presentation. This class is purely responsible for calculations. It doesn't care what we want to do with these values. Do we want to print them on the console? Do we want to write them to a file? Do we want to show them in a desktop application with a graphical user interface? These are all presentation concerns. So in this design, we have moved all the presentation concerns to this mortgage report class. This class gets a calculator, so it delegates all the responsibility around calculations to this class, and it will simply print the results on the terminal or console. Now here we have one more refactoring opportunity. Look at this logic for displaying the payment schedule. So we have this for loop where we initialize month to 1. As long as month is less than or equal to the number of years times months in year, we're incrementing month. Every month we calculate the balance and then print it. Now I would argue that this logic shouldn't be part of this class. This class should be purely responsible for presentation. It shouldn't worry about calculating the remaining balance for each month. So we can move this logic to our calculator class. We can add a new method there called get payment schedule, which will return the remaining balance for every month as an array or list. We'll do that next. All right, now let's move this logic for calculating the remaining balance after each month to our mortgage calculator class. Now here we have to do this manually. We cannot use IntelliJ because it's a special kind of refactoring. So I'm going to copy these two lines here. Now back to our mortgage calculator class. Let's declare a new method, public. We want to return a double array because we want to return a list of numbers. Now technically we could also use one of the collection classes in Java. We haven't covered them yet. We're going to talk about them in the next part of this series. So for now, let's just use an array because we talked about arrays in the first part of this series. So we're going to call this get remaining balances. Now we paste the code that we copied. We're missing one right brace, so let's add that. So here we have a compilation error because we have a reference to this calculator object, but we are inside the calculator class. So we don't really need this. We can call the getYears method, but we can also use the years field directly here. That is better. Next, we have mortgage calculator, the months in year. Once again, because we're inside this mortgage calculator class, we don't really need to repeat this. So let's remove it. Now, what is this expression? This is the expression that we refactored earlier and moved to a method called get number of payments. So let's reuse that method, get number of payments. That's better. Next, we need to call the calculate balance method. Let's remove the reference to this calculator object. So we get the balance after each month. Now we need to store it in our array. So let's declare an array on the top, double array. We call it balances and set it to a new double array. Now, what is the size of this array? It should be equal to the number of payments. So once again, we call get number of payments. So here's our array declaration. We can simplify this by replacing this type with var. That is better. So we calculate the balance after each month. Now we need to store it in this array. So balances of month minus 1. We have to subtract 1 here because the month starts from 1. But as you know, the index of the first element in an array is 0. So we store the balance here, and finally we're going to return our array. Now we can make this code even shorter. We don't really need to declare this variable. It's quite clear that we're calculating the balance after a given month. So let's refactor this. Control T. Here we're going to use the inline command. Unfortunately, it's not visible, so I'm going to bring it up from the top. Refactor inline. So we want to inline all references and remove that variable. Refactor. So our local variable is gone. That's better. Now we have a single statement in our for loop, so we can get rid of these curly braces and clean up the code even more. Now, one more thing. We have repeated get number of payments twice here. We can replace the second reference with the length of the array because they are equal. So we can type balances.length. All right, so we're done with this method. Now back to our mortgage report class. We no longer have to repeat this logic here. We can do something much better. So let me write that code so you can compare them side by side. We're going to call calculator.get remaining balances. This returns a double array, so we can use the for each loop to iterate over this array and get one balance at a time. So we type for double balance colon. So in each iteration, we get a new balance. Then we're going to copy this line for printing the balance and paste it over here. So we replaced these few lines with these two lines. Now, it's not about the number of lines here. It's about the logic. Next time, we want to show the list of balances in another application. We don't have to repeat this logic. We can simply call calculator.get remaining balances. Now, let me show you something interesting. In our previous implementation, we called the getYears method and multiplied the return value by months in year. With this new implementation, we don't need to see this getter from the outside, so we can make it private, or even better, delete it. So back to our mortgage calculator class. Let's scroll down. Here's our getter. Let's find all the usages before we delete this. So it's used only in a single place, which is where I showed you. Now we can safely delete this getter and make this code cleaner. Now back to our mortgage report class. Now look at this expression. Mortgage calculator, months in year. Now we can make this field private, so it's not visible from the outside. It's going to be part of the implementation. So once again, we're going to apply the abstraction principle and simplify the interface of our calculator class. So back to our mortgage calculator. Let's go to the top. Let's find all the usages of this field. So we have used it twice inside this calculator class and once inside our report class. We're going to get rid of that, so it's perfectly safe to make this private. What about %? We only have a single usage of this field, and that is inside our calculator class. So we can make this private as well. So we are hiding all these implementation details. If we change this implementation in the future, the classes that depend on the mortgage calculator are not going to get broken. Now back to our report class. So we're done with this, and we can safely delete the old implementation. Our code is getting better and better with every refactoring. All right, now let's review the code in our mortgage report class one last time. So once again, we can see the encapsulation principle in action. We have encapsulated some state or data and operations around data in a single unit. So we are storing a calculator object in this field, and we have operations around this calculator object. So here we're using our calculator object to get some data and print it on the console. Beautiful. So we have properly separated various concerns. This class is entirely responsible for presentation. We don't have any calculations here. However, I still see one more opportunity for refactoring. Look at this expression. Number format, that get currency instance. We have duplicated that here. We need to store this currency object in a field in this class so we can reuse it in two places. So let's refactor this. I've selected this expression. Let's go to refactor, extract, field. Here we can see the preview of this field. It's going to be private number format called currency instance. And here we can initialize this in the current method, which is not a good idea. We should initialize it either while declaring the field or in the constructor. I'm going to initialize it in the constructor for consistency. Let's go with that. Now we can tick this box to replace both occurrences. Now finally, we need to accept or change this highlighted name. I would prefer to call it just currency. That is shorter and cleaner. So press enter, done. Take a look. Now we have two fields in this class. IntelliJ declared this field as final. So once it's set in the constructor, it cannot be reset. And that's perfectly fine. We don't need to recreate a currency object inside this class. Now, look at our print methods. Our code is cleaner and more readable.